Hello guys, this is Pritesh here from IIT Delhi, and this is a short video presentation on drive details for electric vehicle as a part of our course of automotive system under SPC. So let's begin. So the electric vehicle, which was once considered to be dead, first surfaced about 150 years ago, with first electric vehicle built in 1834 on non-rechargeable battery. And soon rechargeable battery-based electric vehicle, it became popular after the invention of lead-acid battery. But it started disappearing after the invention of starter motor and the mass production of 40 model, which made IC car much more cheaper in comparison to the electric vehicles. Recently, it is becoming popular again. Some of the reasons are, as we all know, that electric vehicles don't have exhaust tailpipe, so it reduces the negative impact of the greenhouse emissions in the environment. And also due to the evolution of lithium-ion based battery, it is commercially viable and available product. Another being it runs smoothly and it is quite easy to operate, and it doesn't have the fuel associated cost as with the conventional vehicles. Here are some of the proposed configuration of an electric vehicle. Here in figure A, it shows an image of front engine forward wheel drive, where an IC engine it is being replaced by an electric motor, while keeping the clutch and gearbox intact, allowing the high and low torque at low and high speed respectively. Where in figure B, it shows some modification, where the clutch and gearbox it is being replaced by a fixed gear ratio. In figure C, we have motor, gear, and differential as a single unit that drives both wheels. Chevrolet Spark and Nissan Leaf is an example of this type. We will further be looking at this ahead. In figure D and E, the differential action it is being obtained by two separate motors for the two wheel at different position, as you can see. And in this figure F, motors are placed inside the wheel to produce the in-wheel drive, and planetary gas system is employed here. So it uses the advantages of high speed ratio and totally removing the mechanical interaction by removing the gearbox. Here are some other configuration that we can employ. We can also have rear wheel drive. Nissan Blade Glider, the given Tesla Model S, is such example. For more control and power, we can also use all-wheel drive, but it also adds cost and complexity. They are useful to provide traction in slippery condition, and also it provides better handling. As you can see, the Tesla Model S also employs all-wheel drive. In-wheel drive. We have looked at it earlier. It reduces the weight of drivetrain by removing the central motor related transmission. Hirico Fold is one such example of in-wheel drive. We will take the example of Nissan Leaf and try to look at its component for drive. Charge port. It is usually located at front of the engine. It allows the connection of external power source to charge the traction battery pack. Nissan Leaf has two charging ports. On the left, it provides quick charging at 480 volt 125 ampere, where current is rectified and supplied to the DC-DC converter directly, which charges the battery pack. On the right, there is two level of charging. Level 1. Charging is done by 3-pin electrical socket at 110 volt 12 ampere. Level 2. It requires a charging station installation by licensed electrician at 240 volt 30 ampere. Onboard charger. When connected to 120 volt AC power source, it steps up, and when connected to 240 volt AC power source, it steps down to 192 volts and rectifies it into DC current. So thus it controls the amount of current flowing into the battery pack. Here is the schematic sketch of battery electric vehicle powertrain. The charge from the battery it gets transferred to the inverter, which gets transferred to the motor, and it provides power to the wheel via a single speed gear with differential incorporated into it. Electric traction battery. The Nissan Leaf 2011 model has a battery pack of 24 kilowatt hour under the floor, which is made up of 48 lithium-ion cell, which is needed to store the energy that the vehicle requires. The battery supplies DC power output to the inverter. Now the inverter converts the high voltage DC current from the high voltage battery pack into the AC current, which is then synchronized to the operating speed of the traction motor. And during the regenerative braking, the inverter converts the AC current from the stator to the DC current, which is then stored into the battery. It adjusts the charging voltage such that the battery array is not overcharged or undercharged. Beneath the inverter, there is a DC-DC converter, which converts the AC into the DC current, which is then supplied to the 12 volt battery, which is used to run the auxiliary in the vehicle. So the motor converts the electrical into the mechanical energy, which is then delivered to the wheels via single-speed gear transmission. Also, many electrical vehicle all has motor generator that can perform the regeneration during braking. The motor that Nissan Leaf uses is an 80 kilowatt permanent magnet synchronized motor. Here is the diagram for it, which has the capability of operating at different speed without any need of gas system. Let's look at the gearbox of Nissan Leaf. It has gear reduction unit, typically around 8 to 1 single speed gear. It has differential gas head incorporated into it, which divides the torque equally to the left and right drive wheels. As you can see from the figure here, the shaft from the motor is connected to this gear, which turns this gear, which has a speed reduction of 8 to 1, which in turn drive this gear, which has differential incorporated into it, which then supplies the torque to the wheel on the either side from the spline shaft. As you can see, it doesn't have any other gear ratio. So reverse, in order to move in reverse direction, we have to supply the current in reverse direction in the motor. It also has a parking pole motor, which is an electric motor which locks the final drive when the shifter is in park position. So let's look at the power and torque characteristic of an IC engine and an electric vehicle. So a vehicle, in order to meet its operational requirement, it requires high torque and low speed for starting and a high power at high speed for cruising, which as you can see in the diagram, it is provided by the electric vehicle, which has the high operational band for low and high speed respectively. In the IC engine, as you can see, the requirement of high torque it is fulfilled by the first gear, and the requirement for the high power it is fulfilled by the fourth gear. So that's why an IC engine needs a different gear ratio in order to function. Here is another curve which compares power versus torque for an IC engine. So in conclusion, we have looked at the various advantages of the electric vehicle over the IC engine. In order to recall it, so let's conclude what we have learned today. The electric vehicle it is supplied through an AC power source through a charging port which is at the front of the vehicle, and the onboard charger it converts the AC power source to a DC power source, which is then supplied to the lithium ion battery, and alternatively we could charge it by the DC power source which directly supplies to the lithium ion battery. The DC-DC converter, which is placed just underneath the inverter at the front of the vehicle, it it is used to supply the high voltage DC power source, to a low-voltage DC power source to charge the 12-volt lead battery, which is then used to run the auxiliaries in the vehicle. The inverter, which is placed at the front, is used to convert the DC power source from the lithium-ion battery to the AC power source, which is then supplied to the motor. The motor here used is permanent magnet synchronous motor, which is used to provide the necessary torque to the wheel via power transmission system, incorporating a single speed ratio and a differential in front of it. So here are some of the references that I've used, and thank you for watching it.